you or a loved one ever wondered on how the universe came to be scientifically? Well, wonder no more. No more. We, the Group 7, are here to explain the 4 different scientific theories of the beginning of the universe.
Hello, I'm Alexi, and I'm here to explain the Big Bang Theory. I'm going to space. Come with me. And now we're in space. The Big Bang Theory states that the universe began as a hot and indefinitely dense point. About 13.7 billion years ago, this tiny little dot exploded. And from this explosion, all matter and all energy and time was created. From what once was a dot turned into a universe that is still growing and expanding to this day. From Belgian priest Georges Henry Joseph Edward Lemaitre. He is the one who suggested the idea of the expanding universe, and he is also the first proponent of the Big Bang Theory. Next up, Edwin Powell Hubble, creator of Hubble's law. He provided evidence that the universe was not static, but was indeed expanding. And lastly, Arno Penzias and Robert Wilson. They both discovered the cosmic microwave background of the Big Bang. Though of course, this theory has its drawbacks. The first law of thermodynamics says that you can't create or destroy matter or energy, which this theory very much violates. It also fails to cite how the universe began or how the galaxy was formed. But hey, that's just a theory. A scientific theory. And now, here's Kate with Steady State.
Thank you, Alexi. Hi guys, today I'm going to show you how the universe began in steady state theory. The steady state theory suggests that the overall appearance and density of the universe will not change over time, even if the universe is continuously expanding. On the grand scale, the universe has a particular end or beginning. The steady state theory was first proposed by Sir James Jeans in the 1920s, but it really got a boost in 1948 when it was reformulated by Fred Hoyle, Thomas Gold, and Herman Bondi. There is a dubious story that they came up with the theory after watching the film Dead of Night, which ends exactly as it began. The universe expanded and cooled ever since it was extremely hot and dense at its inception, 13.7 billion years ago. Now, it is accepted by the vast majority of cosmologists. While not necessarily true, the steady state concept was popular for a while. The ideal cosmological principle serves as the foundation for the steady state theory. The universe expanded and cooled ever since it was extremely hot and dense at its inception, 13.7 billion years ago. Now, it is accepted by the vast majority of cosmologists. While not necessarily true, the steady state concept was popular for a while. The ideal cosmological principle serves as the foundation for the steady state theory. As a result, any indication that the universe evolves contradicts the steady state theory. As a result, any indication that the universe evolves contradicts the steady state theory. The existence of quasars, as well as a change in the rate of expansion of the universe a few billion years ago, are the evidence against the steady state.
Welcome, ladies and gentlemen, to a fascinating exploration of the oscillating universe theory, a concept that unveils a captivating possibility about the nature of our universe. So, what are we waiting for? Let's get this space journey started. The oscillating universe theory is proposed by Richard Tolman. According to his theory, our universe undergoes a never-ending cycle of expansion and contraction. The oscillating theory proposes that the expansion will eventually slow down and reverse its course, leading to a process known as the Big Crunch. During the Big Crunch, the universe contracts under the influence of gravity, bringing galaxies, stars, and other cosmic structures closer together. Eventually, this immense contraction culminates in a singularity. The oscillating theory suggests that our universe has experienced numerous cycles in the past and will continue to do so in the future. Each cycle brings forth new possibilities, new formations, and new opportunities for life and exploration. Thank you for joining us on this mesmerizing journey through the oscillating theory.
Now that you've learned the different theories of how the universe began, let me now show you the origin of our solar system. The nebular theory is the most widely accepted explanation on how the sun and the planets in our solar system may have formed. When the solar system was first created, all that was thought to have existed was a cold, spinning cloud of gas called the solar nebula. The nebula, or what we call the cloud, resulted from an uneven distribution of gases throughout the universe. As the gravitational pull began to condense the gas toward the center, the speed of the rotation increased. The cloud collapsed then for some reason.
A shockwave from a nearby supernova probably initiated the collapse. As the nebula collapsed under its own gravity, it spun faster and flattened into a disk. And as the temperature continued to rise, a ball of hot gases formed in the center of the disk, creating a protostar, or what we call the sun. Dust and grains surrounding the sun eventually formed clumps. These clumps accreted, forming planetesimals. A small celestial body that once collide together tends to fuse to form the planets.
Metals and silicates could exist near the sun because these compounds have higher boiling points. As a result, terrestrial planets including Mercury, Venus, Earth, and Mars were eventually formed, containing higher concentration of these compounds. Jovian planets composed of Jupiter, Saturn, Uranus, and Neptune are huge planets made up of gases without land surfaces. These planets were formed farther from the sun because the temperature is cooler enough for the gases to condense, creating these massive but low-density planets. This theory can be credited to Immanuel Swedenborg, Immanuel Kant, and Pierre-Simon Laplace.
And that concludes our group presentation on the different scientific theories. We hope you learned something. Good night, folks.
Who's afraid of the big bad wolf?